Okay, now let's take a look at some examples. For this episode, we'll go ahead and just look at example 1. So I'd like you to pause for a second here in the video and then read through this. Maybe make note of any pertinent information or underline any pertinent information if you have a copy. So go ahead and read through this. Okay, so a couple things you'll notice. First of all, our sample size here is 36. So I'm going to make some notes here that n is equal to 36. The sample, the average home loss was $9,500. So that's going to be our sample mean. Our sample standard deviation was $1,500. So that's S. And then also you'll notice that it says that the distribution was slightly skewed. Okay, so first of all, A says check the conditions for creating a T interval. And I'm going to go ahead and extend the page here a little bit. But it was slightly skewed. Okay, understand that the distribution is slightly skewed. So if we're going to be able to create a T interval, we have to be able, the sample we use has to be larger than 30. Otherwise, we wouldn't be able to do this. So as you notice up here, we said there's 36 bits, so the sample size was 36. So in other words, for part A, we can use a T distribution. Or in other words, we can use a T interval. We can actually construct a T interval. I shouldn't say use, we can, because our sample size was 36, which is larger than 30. Now again, as long as your sample is larger than 30, it doesn't matter what your original population shape was. We're going to use a T distribution or T interval. So B says now construct a 95% confidence interval. So if we do that, then what we're going to do, and here's the formula, we're going to take our sample mean plus or minus our critical value of T times, and T, and remember that's alpha divided by 2, don't worry about that. And then we're going to take that times our standard error, which is our sample size divided by the square root of n. Now one thing I haven't stated here yet is what is our T value? Well, we can use, normally we use a table, but ladies and gentlemen, we could use our stat app for that. So I'm going to go ahead and go to my stat app here, okay? And if you go to, again, it's down toward the bottom. You got to go a little ways. If you go to T distribution, it's right next to the normal distribution. And we're going to go to find percentile or quartile, the third one. And what we're going to do is we're going to look at our degrees of freedom. Now, if you go back here, since the sample size was 36, the degrees of freedom is always 1 minus that. So degrees of freedom is your sample size minus 1, which would make this 35. Okay? So if we go to our, go right here for degrees of freedom, we put 35. And confidence intervals are always two-tailed tests. So what I'm going to show you here is, ladies and gentlemen, this right here is the middle 95%. Now remember, we're finding a 95% confidence interval. So right in the middle here matches up with the degree of confidence that you want. Outside of that, right here and right here are alpha. Well, I should say, remember, 95% is your confidence level, then alpha is 5%. But the thing is that 5% gets split between the two tails. So in other words, alpha here has to be, half of alpha has to be here, half of alpha has to be here. So that's where we get that T of alpha divided by 2 is because we're taking alpha and splitting it amongst the two tails. So half of alpha is 2.5% here, half of it is 2.5% here. And again, we really don't have to do a whole lot with that, ladies and gentlemen. On confidence intervals, we do have to do more with it when we get to hypothesis testing, but I kind of wanted to show you that. All I want you to really be concerned with is this, ladies and gentlemen, that this middle 95% is your confidence level, okay? If this were a 90% confidence interval limit, this would read 90%. If it was a 99% confidence level, this would read 99%, okay? But the thing we want to get from this is here. Right here, are your two critical values. Now, one's positive, one's negative. Don't have to worry about that. The only thing we have to worry about is that our critical value for t is just 2.03. Just take the absolute value of it, okay? So that is our critical value, 2.03. So if we go back here to our formula, and I'm going to extend the page, okay? So really all we need to do is to fill in the values. In other words, X bar, the average, and I know I got this sitting up in front of here, was $9,500 plus or minus. Our critical t value is 2.03. Again, you just use the absolute, you don't have to use the plus or minus, times our sample standard deviation, which was 1,500, divided by the square root of our sample size. Do not use the degrees of freedom, use a sample size of 36. Okay? I might go over a little bit over 7 minutes on this one, but if I do, it's not going to be too much. So now after you do your calculating, we get 9,500 plus or minus 508. Now this 508 right here, ladies and gentlemen, that is our margin of error. That value right there is your margin of error. Okay? So how do we get our two interval limits? Well, the bottom one, the lower confidence limit, you take 9,500 minus 508. The upper one you get by taking 9,500 plus 508. And if you do that, here's what we get. We get the lower limit would be $8,992, and the upper limit would be $10,008. Now, what goes in between there is less than, and we're estimating the population mean and then another less than. So really it's a three-part inequality that basically says we believe that in this interval, the true population mean falls between $8,992 and $10,008 for the typical average loss of a home. So again, that's how you calculate a confidence interval limit. Now, on the next video, we'll finish the rest of it.